Hi, my name is Tin Thuấn, and today I would like to present to you about the midterm report for Project B of Data Science in the University of Adelaide. So my project is about data augmentations for machine learning-based software vulnerability assessments. So in this presentations, I would like to divide the presentation into four parts: the background, the methods, the results, and the conclusion. First, let's talk about the background of the research. So this research is about the software vulnerabilities for software developments. So according to the U.S. Homeland Security, there are about 90% of security incidents is caused by vulnerabilities in the software layers. So especially like many companies have placed significant network securities, but 90% of cyber attacks are happening on the application layers. Uh, for example, the Equifax in the 2017 is caused by vulnerabilities in the Aperture Group web development framework, which cost the company millions of dollars. The same can be happens, which can take into risks such as security breaches, malware and ransom attack, denial of service, regulatory and compliance risks with users. So for that reasons, many IT securities professionals, researchers, and analysts, as well as software developers, create the new database, which is called the National Vulnerability Database (NVD), which provide developers with the common vulnerability exposures for new vulnerability and bugs or errors, with the CVSS metric to evaluate their severities and integrity, which impact your software. So multiple researchers also using this database to create machine learning techniques or deep learning techniques to extract data from NVDs, then building the natural language processing models to predict the impact of the breach based on description and the code alone to reduce the manual work done by professionals, IT professionals. NVDs provides us with a public API for vulnerability description as well as CVSS metrics for evaluations, which can be seen here. So the current data sets contain like 180 million vulnerabilities from 1988 until 2022. We only, and for the purpose of this project, we only analyze and perform predictions on the following list of CVSS metrics such as CVSS vector string, CVSS access vector, CVSS complexities, CVSS authentication, CVSS confidential impact, CVSS integrity impact, CVSS availability impacts, the base score, and all is sorted using the published date of the vulnerabilities. Due to the large dataset, we split the data into 5 equal chunks and run 3 times with validations and tests to help run the dataset on the current softwares. So we dive deeper into this dataset and notice some imbalance between the classes in each metric. For example, the most severe imbalance is occur on the vector, access vector, and authentications metrics, which can make the models become more biased towards one majority class why have hard time predicts on the minority classes. So one of the recommendation methods for helping to solve the imbalance problem is the uh, data augmentation techniques. These techniques are powerful techniques used by machine learning and deep learning models to artificially create new sample on the data training set based on the existing data. The goal of data augmentation is to generalize, and increase the robustness of the models while mitigating the limitations or the limits of the imbalanced dataset. This is especially very good in the MBD case because these gen errors is managed and created manually by IT professional, which can it's hard to ensure the balance between the classifications and harder to control. In the previous papers, there are multiple people working on this kind of problem in NVD, such as the Spanos in 2018 paper about the multi-target estimation of software vulnerabilities and severities. In this research, they're using multiple models such as random forest, XGBoost, decision trees, which shows moderate to high good performance results. However, they also noticed that the imbalance problem can result in unreliable result, as well as suggestion on multiple boosting data for the minority class to mitigate the problems. The ZIM's papers also have another approach on the MVD database, which using the input is the C code to create predicts the net CVSS matrix using the deep learning natural language processing models to predict this kind of matrix. For as well data augmentations for NLP, we have previous paper from Bears from 2021, which provide multiple data augmented implementation of framework, such as basic data augmentations, and as well as listed some challenges and some challenges on the data augmentation implementations, which can be tested and see in this project. Another techniques recommended by Rubos in 2020 papers, which related to the the GPT-2 models, which rely on the highly pre-trained language model based on a specific domain of words such as hospital data, technology data, which can be a good next step of future investment. But due to the lack of processing power and hardware, we are still not we will not implement this kind of techniques in our projects. So the goal for this project is to improve the performance of models by balancing the class used in on multiple CVSS metrics to increase the bias and improve the robustness of the models. We also doing some experiments with multiple data augmentation techniques and compare them between machine learning and deep learning models. So in this project, we will build the following models. For machine learning, we will build logistic regression, support vector machine, k-nearest neighbor, regressions, rainforest, XGBoost, LGBM. For deep learning, we're building the machine learning, the MLP, the CNN, and lastly, the STM models. Uh, as we said before, the data can be downloaded in the public API and stored into the NoSQL database for further processing. We follow these general rules of workflow when working with the data and the models. So after saving the data to the database, we can store the data based on the public dash and maybe perform some data augmentation technique which related to context, for example, back translating or synonym to ensure the context of the new data. Then we can clean the stored word and standardizing the word format. So to ensure the data, the input data to the model is reliable. So after cleaning, we can apply some other balancing techniques such as data sampling, such as oversampling, undersampling, or data augmentation techniques such as random insertion, random word insertion, random word substitution, random word deletion, or the combination of insertion, substitution, and deletion. Then, as many others MLP models, we perform techniques as backward, CFIDF, Doc2Vec to generate a word vector or vocabulary for the model to learn. Then we apply to the model as discussed before. After fitting, training, validations, boosting, and prediction on the test model, we can evaluate the results using the MCC score generated by the models. So we come to the next part, is the result analysis. So in part A of this project, we successfully built the foundation pipeline for the machine learning-based vulnerabilities. The pipeline, as we discussed before, the pipeline including feature extraction techniques to the vectors such as backward, Doc2Vec, TF-IDF, and compare between them. We console and also some data set balancing techniques such as oversampling, the samplings, and the six random word insertion, random word substitution, random word deletions, and the combinations of three methods. And lastly, we're building the 6 machine learning models. So let's review some results from the last time. So we can compare the performance with each models in the average MCC score. The best performance models are XGBoost and LGBM, which about 31% score, which is relevant and equivalent to the others paper work in paper before. And if we look closer when comparing the data augmented techniques on the 2 largest models, best models, XGBoost and LGBM, we can see that the when we don't apply any data augmentation techniques, it's generally perform the best on machine learning, which is and followed by the oversamplings. However, some basic data augmentation techniques such as random insertion, random substitution, and deletions result in worst case. And finally, the technique which remove the vocabulary such as undersampling and deletion generate results the worst. So in part B, we focus on building the deep learning models to learn out about each individual techniques. We also compare the effectiveness of each data techniques with the best model from the machine learning the average of the evening also. So in this table, we can see that the NLP performs generally worse, which require more tuning and running, fitting again to enhance the performance. But the LSTM and CNN perform generally better than the machine learning, and the average of the machine learnings, which like from like 10%, and the data augmented techniques such as insertion, substitution, and deletion perform better than when not applying any techniques different from the other from the machine learnings. So as we can see, the most effective models from all the model we run is the LSTM models, which result in the data simple data augmented techniques such as random insertion, random substitution, and random deletions perform better than the original data, and oversampling and undersampling techniques. So in conclusions, we in this project we present a comprehensive structure surveys of data augment techniques on for natural processing language on the MVD datasets, especially the vulnerability description. We also provide the background for data augmented techniques for popular NLP application. Finally, we outline the current result, plan, and suggest some new technique for future project. In the conclusions, deep learning models such as CNN and LSTM usually improve the effectiveness of the models, while machine learning techniques such as XGBoost and NGVM, the performance is not improved. So I want to express my thank you and gratitude to my teacher as well as my supervisor, Dr. Trickley, who gave me the opportunities to work on this project and provide valuable support during the time. I would like to also thank my family, friends who helped me with the emotional and mental support during the projects. Thank you for listening. If you have any questions, please don't hesitate to email me and call. Thank you for listening.